this time be okay. Okay, can you hear me? All right. Okay.
Yes, sir.
So okay, before we start, do you have any question from the homework I give you last time? Problem with the homework questions? Okay, you did number 30. The one that I asked you to do number 30 to set up the table, identify the variables, get the inequalities. Okay, you did that? All right. So, okay, all right. So let's continue with the regular discussion. Zoom wants to share content of your screen. Share system audio. Share. Window. Itu dia. Ini benda baru kan ni? Dia lain sikit daripada biasa. Okay, so we continue from where we left last time. Right, can you see the screen now? Can you see the notes?
Yes.
Yes.
Tapi saya tak boleh ni. Selalu when I share screen, I still can see this one. But this time dia lain sikit. When I share screen, tak ada benda nampak. Dulu, we can ada lagi kena buat apa-apa kat sini. Dulu, when I share screen, benda tu ada. Alright, tak apalah. Okay, we continue. Okay, so this is where we stopped last time, and then we will continue. Today we are going to look at the system of, we already have looked at the system. We're going to look at the optimization problem. So today, optimization problem, that is the application that we're going to look at. Now, optimization problem. This is what we call, you have the problem. We want to maximize optimization problem. You want to maximize or minimize. This is the problem. Maximize or minimize an objective, the objective function. Okay, an objective function subject to a set of constraints. So this is our optimization problem. Now, we have here two things. One is the objective function. So objective function is a linear function. Okay, objective is a linear function. Now the constraints, all right, here, these are inequalities. So here I have a system of inequalities. So that is our inequalities. That is our optimization problem. So you want to maximize the objective, which is linear, given, subject means given, given the constraint, which consists of what? Consists of a few inequalities. So that is our problem. That is our optimization problem. So you want to find, to find the maximum point or minimum point. That depends on our problem, whether you want to maximize or minimize. And of course, we will do that subject to a constraint, a set of constraints. So therefore, it's not just purely maximization or minimization. It's maximization or minimization of the objective given constraints. So we optimize, we optimize. So that's why you call it optimization, because you maximize or minimize given some constraints. Now, how are we going to do this. All right, this is the problem. Suppose I will start with maximize. Okay, maximize objective. Now we're going to look at an example. Objective function. Say, I will start with a general. Yeah, general. Ax plus by equal to c. So that is our objective function. Subject to. St means subject to. Okay, subject to some constraints which consists of a few inequalities. It's like a system of inequalities. So suppose you have a1x plus b1y bigger or equal to c1, call it number 1. And then I have a2x plus b2y less or equal to c2, call it number 2. And then you have a3x plus b3y bigger or equal to c3. So you have these constraints. The most we will have, three inequalities. Sometimes we have only 2. So, for ours, we have 3 or 2. But you can continue to have 4 or more, whatever number of inequalities, doesn't matter. The thing is, what I want to show here is you have the objective, right, which is the linear function, and then the constraints are inequalities. So that is our general problem. Now we will start with an example. Suppose I will consider an example. And to do that, let's go back to one of the things that we already did, so that it will be easier, for me to look at the examples inequalities. Tak payahlah kita nak cari balik. Okay, so let's go back to the things that I already have. Okay, so let's go back to these inequalities. I already have these inequalities, so we just take it as the constraints. So I have to write down. Sebab kita pergi the next part ni. So you don't have to write down, all right? You write down afterwards. I have to write it down because I could not see this after. Ni berapa ni? Negative 4x plus berapa y tu? 3y. Plus 3y bigger equal to 40. And then I have 4x plus 6y. 4x plus 6y less than, 4x plus 6y are less than 100. And then I have another one, x bigger or equal to negative 20. So that is our constraint. So the problem is this, okay? I have this so that, we already have the graph. So it's easy for me to refer. So the example, let's say I want to maximize objective function, say 3x. I have already 3x. Say 2x plus 5y equal to some constant, call it c. All right, call it c, constant or k, where c constant, right? Where c is a constant. I put a bracket because we sometimes we know that will be a constant subject to. Okay, these are the inequalities. The constraints subject to the constraints negative 4x plus 3y bigger or equal to 40. Call it number 1. And then I have 4x plus 6y less or equal to 100. 6y. And then we have x bigger or equal to negative 20. Call it number 3. So that's the problem. I maximize an objective all right, which is what? Which is a linear function given this constraint. Okay, now, how do we do this? Okay, I will summarize the method. And this method is a general method. Okay, general method. Number one, you start with the constraints. Okay, constraints, and we already know this, which are the inequalities. Okay, which are a system, or which is a system of inequalities. So what you do here, you graph everything. Okay, graph, draw the graph. Don't just sketch. Depending on the problem, it's better to draw. You draw the graph, and then you identify the feasible region. Okay, identify the feasible region. So we know this, we know that. And then determine the corner points, all corner points, which we already learned. So first part, nothing new. Okay, nothing new with regard to the inequalities. We draw the system, we draw the graph, identify the feasible region, determine all the corner points. I say determine, you have to find the points, okay? You have to find the points specifically. If you draw the graph very good, in terms of the scale, the interval, you may be accurate. But if our drawing of the graph with the scale interval is estimation, we have to find, okay? Because if you just locate it by the graph, it will not be the right values of X and Y. So you do the graphing of the inequalities, determine the corner points. What you do next is, number two, the solution, okay, the solution to the optimization problem, the one that you want to maximize or minimize, the solution, okay, the maximum point, correct? Or if our problem is minimum, then it's the minimum point would be what? Would be one of the corner points. So I say corner point, CP means corner points. So the solution would be one of the corner points. So you will not be having solution any point in the feasible region. The solution will be one of the corner points. Okay, all right. So number three, since we know that the solution would be the maximum point or the minimum point, depending on the problem, since we know the solution will be one of the corner points, so it is good that we tabulate the corner points. Okay, you tabulate the corner points, and then what we do, we substitute each corner point into the objective. All right, into the objective function. And then we identify the solution. So just identify the solution from the table. So you identify the solution, that means it's the maximum point or the minimum point, depending on the problem. So for our example, you want to maximize that objective function given the constraints, which are the inequalities. Then you substitute, you will get what? You will get, or you identify the maximum point. Okay. All right. Any question? So what I want you to do, okay, you go back to the graph that we have here. I think I asked you to find feasible region. Yeah, you got already the feasible region. I want you to find point A, point B, point C. Not just estimate by looking at the graph. You have to determine. Okay, you have to determine. That means you have to show the work. So in order to do that, we already know the method. So once you draw the graph, okay, once you draw the graph, which is step number 1 that we already did. So number 1, done. Okay, you already have the graph. Number 2, determine the corner points. So you need to find point A, point B, point C. Okay, how do you get point A? Point A, to find point A, what? It's the what? To find point A, you have to solve the system. 4x plus 3y equal 40. And then you got 4x plus 6y equal 100. Call it number 1. Call it number 2. You solve it, you got. So similarly for B and C. So I want you to find it. All right, you work it out. If your name is from A to H, you do point A. If your name is from Hijkii to S, you do B. If your name is from IST, okay, if your name from T to Z, you find point C. Okay, do it now. The first person who get the points, let me know so that we don't waste a lot of time. Okay, do it now. Get the points. Show the work. Okay, I give you 3 minutes. Show the work. Get the point by the substitution method. Don't just look at the graph, because we want to get the exact point. Start video. Start video. Ini dah recording. So video ni lain. Okay, you got it? Okay, anybody got the solution? Hello? Boleh dengar ke tak boleh dengar?
X equal to 1.67.
Okay, point A. Point A, what is point A? After you work this out, you will get, I will tabulate the points. So you table the points, okay? So here are the corner points. Point A, berapa tadi? 1.67. Point A. Okay, if you look at point A, somewhere, betul lah tu, the origin. Okay, 1.67 berapa? What is the value of the Y? Okay, point B. Anybody got B yet? B and C should be easier lah. That's why I give more people to do the point A. Okay, point B. Anybody got it? Hello? Boleh dengar tak? Boleh dengar ni? Anybody get the point B? Yeah. C. Point B in C is now. Yeah, you know, the X is negative 20. You need only to find the value of the Y. Okay, what is the value of the Y for B? Hello? Ada orang kita orang ni? Ke tak dengar?
Yes, sir.
Berapa minit nak buat? You know, these are simple things. If the simple things we cannot do, berat. Okay, but these are the simple things that we should be doing very, very quickly. Okay, point A, B, C, whatever. Whoever get the point, let me know. Either B, C, A, it doesn't matter. Alright. Taklah, point B ke C ke tak kira.
For point A, I got 15.56.
What is that 15.56?
For
The
A,
value of Y. For
Y,
A, I know. Y.
Y.
For 14, yang
15.56.
yang X betul 1.67, 15.56.
Yes. 56. Yes.
Okay. X, correct. X to 1.67, betul ya?
Betul.
So X is 1.67, Y is 15.63. Okay, anybody get a different value? Or is that the correct one? So if I go back to my graph, this is 10, that is 20, so about right, okay? And then that is point A. Okay, right, good. Anybody get the different value? So make sure you know we are correct. Okay, point B. What is the value of Y at point B? These people ni, yang from your name I to S. You know, what is the point B? Right, so apa tu dapat?
So is it negative 13.33?
I don't know because I'm not the one doing it. So whatever you get, you tell me.
I got negative
What is
13.33.
it? Negative 13.33.
33. Yes.
Okay, good. So betul ke tak betul? Anybody, somebody else check? If you have the same value, that means that's correct lah. If it is not, that means something wrong.
Same value.
Okay. Same value, betul lah tu. So if you look at point B, 13 point. 13 lah. Sebab dia atas daripada 20 ni. So maybe that
Where is
is
that? I got
not right.
30.
30. Yeah, it should
0.
it should be above 20 because we draw the graph, we didn't sketch it. Should be negative apa? Anybody else get another number?
I got 30. 30. 30.
30 bulat eh? Okay, so that is 30. Okay, check balik. If you get that negative 13, maybe not point B. Maybe what you get negative 13 tu, it's point C. Point C is logical because you have, you know, a negative value there. But it's between point C, the value of Y should be between 0 and negative 10. Okay, anybody get C? What is the value for Y? Let's see.
Negative 13.33.
Negative 13.
13.33.
So yang tadi itu C lah, bukan B. So you are right. It's just that it's point C. Betul tak? C kan? So those are the corner points. So the solution would come from one of these corner points. Now, if some people still cannot find the solution to the system of linear functions, you better spend more time lah working. Okay? If you just look and don't do work, then it's not mathematics. Mathematics is write, do it. Okay? If you just write, you think that we know, that is not enough. Okay? You have to do it. You have to practice. Okay? This is not just reading history. All right? This is a different thing. So you better work more. Okay? For those people who still have problems getting these simple things, you have to spend more time. Okay? Okay, corner points. So now what we do is we substitute these values into the objective. So the objective was, if I go back to the problem, objective is objective 2x plus 5y equals C. So we put into that objective function. So the objective is 2x plus 5y equals C. So we're going to find what is the value for each of the corner points for the objective. So we do it one by one. So first you do for point A, we do the substitution. So we do it right away here in the table. So you got 2 multiplied by 1.67 plus 5, 15.57. Okay, what is it equal to? So for those people who do the point A, get the value. I will just write down here, and then for those people who do B, okay, find the value of the objective at B, and so on. So I have here 2 negative 20 plus 530 and equal to. And here I got 2 negative 20 plus 5 negative 13.33. Okay, find the value. All right, for point A, what is the value that you got?
81.14.
81.14. Okay, another person, do you get the same value or you get another value? Just to verify. Same, sama kan? All right. Now for point B, what did you get?
110.
110. All right. C?
Negative 106.65.
Negative 106.65.
65.
So what you see here when you do the substitution, you get a different value of the constant C. Okay, you have a different value for this one. So that will give you different values. So now what you do, we just identify. All right, we identify the point that solves the problem. Okay, so if I go back to the problem, that example tadi itu, example yang ni, you want to maximize. Okay, so when you want to maximize, we are looking for what? We're looking for the maximum value. So I got here 81.14, 110, negative 106.65. So therefore, we can see, okay, we can see that this is the maximum value to the objective, which is 110. So the maximum value to the objective is what? Is 110. And what point, okay, what point give you 110? Which is what? Which is negative 30, no, I'm sorry, negative 20, 30, which is point B. So that is our answer. All right, we just do it by what do you call it? By observation. That's to identify the correct answer. Okay, all right. So what our conclusion is, to maximize, okay, to maximize or to solve the problem, to maximize the objective, we have to maximize the objective, the point, okay, the point is, or you can say the point, whatever the point is maximizing the objective. Or I say the other way around, to maximize the objective, the point is B, all right, which is negative 20, 30. Or you can, I think, better you put the other way around. The point B, negative 20, 30, maximize the objective, subject to the constraint. Maybe the second version sounds better lah, than the one that I write here. But it's okay, all right? You write the second sentence. The point B, which is negative 20, 30, maximize the objective, subject to the constraint. Or you can write to maximize the objective, subject to the constraint. But you don't have to do that, because we know that is the problem, you know. The problem is subject to the constraints. But this is what I mean.
Sir, sorry.
Point is,
Sir, sorry.
Yeah.
Macam, how did you determine B is the maximum to the objective?
okay, how did I maximize, how did I know the point B maximize the objective? Okay, you go to the table again, tell me. Okay, how did I get point B?
Because P is the largest one.
What is the largest value?
110.
Oh,
110.
110. Okay.
110. Okay, the largest value is 110. And which point give you 110?
B.
B. Okay,
Okay,
you got
thank
it?
you.
Okay, good, thank you. So that is how we get the point. And we can say, okay, we say that the maximum value is what? Is 110. So either you put the second sentence first, or you can put this thing first, it's okay. You can say the maximum value is 110, and the point that give you the maximum value to the objective is point B, negative 20, 30. But here I put the other way around. I put the point first and then the value. You can say the value first and then the point. Okay. All right. Any question? Now suppose, okay, suppose the problem is instead of maximizing, you minimize. So I go back to the problem. Okay, the problem that I have here, suppose now minimize. Now, if it is a minimization, everything remains the same. Okay, everything remains the same up to the table. No new change. Okay, no change. Nothing is different. Up to the table, everything the same. So what is the difference now? If the problem is minimization,
Need to find
Yeah,
the
the lowest.
smallest value.
then you have to find the lowest value. Okay, so if our problem is minimization, then we identify which value is the minimum and what is the point that give us the minimum. So the only difference will be just the answer, the solution, the answer. The solution is the same, okay? The method is the same, everything is the same. The only difference will be the problem, because you have minimization, and then the answer will be the problem. It will be different. So if I have a minimization, right? So we say that the minimum value is, or you can say the minimum value of the objective is, but I don't think you need to that, because we know already is negative 106.65. .65, and you can put another sentence, and the point, okay, C, which is negative 20, negative 13 point, negative 13.33, negative 20, negative 13.33 give the minimum value to the objective. Okay, it'll be something like that. So what we are doing, we describe, okay, we describe the point and we describe the value, whether it is a maximum or a minimum. Okay, any question about this? So nothing new, all right? Everything we have learned, the only difference will be, or the only new thing is the table, where you summarize the corner points, and then we identify the answer. So that would be 4.2. Okay, 4.2. I give you one question. Okay, I want you to do it. Okay, I'll give you some homework question first. All right. Okay, homework question. I would like you to try do these questions. 4.2. Okay, do number 10, 12. All right. Now I want you to do it in class now. Okay, the one that I want you to practice now. Okay, I want you to do the question number 14. Senang. Okay, that question is a very simple question. The inequalities are small value inequalities, so you can find easily the intercepts. So I would like you to do that question number 14. Okay, do it now. I give you 7 minutes to do this. Okay, the only thing is you have the inequality y less or equal to 2. So I hope we can identify that that inequality y less or equal to 20. Okay, all right, do it now. I give you 7 minutes. I hope everybody can do it in 7 minutes. Okay, you will have you have 0, 9, 9, 0, 0, 9. Okay, I give you this question, simple question. The questions are easy for us to draw. All right. So you draw it. Cepat sikit lah. Okay, you got the graph.
Yes.
Okay, good. So when you got the graph, kita kena cari the feasible region, and then you have to find the what do you call it? The corner points. So based on the points that we have, okay, you draw the graph. So 0, x, y. I can use here a scale of 5. I think 5 would be good. You can use 10, 5, 5, 10, -5, -5. So first point is 12, 0, 0, 3. 12, 0 be somewhere here. 0, 3 be somewhere there. Is that right? Okay, when I draw this, you check yours, let me know. Probably I make an error. Betul tak? Betul ya? Betul ya? So this is 4x, no 4x, x plus 4y equal 12. You want what? We want less than. Okay, less than, up or down?
Down.
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 You test 0, 0, you get 0, will be less than 12. So this would be our inequalities, our inequality. Okay, so you label that x plus 4y less equal 12. Now for the second one, you have y less or equal to 2. So 2 will be somewhere here. 2 here. Tadi y equal to 2. Sini lah. Alright, y equal to 2 kan? Y equal to 2 is the horizontal line. So that is y equal to 2. We want less than. So less than will be the one below. So here, y less equal to 2. Okay, betul eh? Everybody got it? Okay, for the third one, you have 9009. 90 is somewhere here. I use another color. 90 will be somewhere there. 09 will be somewhere there. So 09 90. Salah. That was not right. Okay, but it's easy. It's difficult for me to erase, because if I erase, I got to redraw a few other lines. So it should be here though. So that is x plus y equal 9. You want less than, should be here. Okay, now where is the inequality? Inequality. Where is the feasible region? Okay, if you look at the question, okay, this time we may put the additional simple inequalities. x bigger equal to 0, y bigger equal to 0. Otherwise, we may have only. All right, let's start without the x bigger than 0, y bigger than 0. If you have only these three inequalities, without the x bigger equal to 0 and y bigger equal to 0, where is the feasible region?
09.
09. 09 will be here. 09. 09. And then
0,
No,
0, 0, 3.
not the corner points. All right. I want you to give me the feasible region dulu. Feasible region dulu. The area. Don't take this into account yet. Okay. That one will come afterwards. I want you just to give me the feasible region for the one that I draw. Yeah, 3 inequalities. Just feasible region. Okay. Not the corner points. Okay. Where is the feasible region? Anybody who got it? Intersecting area je lah. Okay. Cepat-cepat. For the first person who identified, let me know.
The trapezium tu sir, yang 00202.
Yang tu lain. You tell me the area first. The area from where to where? What line to what line? Okay, cepatlah. Give me the line. The from what line to what line? Cakap je. If you look at my graph here, I use red line, blue line, black line. So you can tell me in terms of the red line up to where, the blue line up to where, or whatever the black line. Okay, tell me now. Just look at my graph.
The blue line up to 9 and the black line up to 3. And then the red
Okay, the blue line up to
9.
9. Here. Oh, yang ni, sini. The blue line up to 9 here. After that,
The black line up to 3.
the black line up to 3.
And then the
After
red
that,
line. The
red line.
red,
Okay.
the straight line.
Betul tu. Half betul, but it is not right. You got half correct. Okay, check balik. Where is the feasible region? You got the thing half right. Or the blue line up to here.
Yeah.
Up to I think the blue line is not up to 9, up to here. Yeah, up to here. The blue line up to here, and then the black line up to there, and then the red line. There. You have the feasible region. Therefore, bounded by this line, the blue line, from the bottom, not up to 9, up to where it intersects x plus 4y equal 12, the point. And then it will be what? It will be the black line up to here, up to x equal to 3. Okay. And after that, the red line for y equal to 2. Betul tak? So this is our feasible region. Okay tak? Betul? The black line, okay, the blue line up to here, and then the black line up to here, after that red line. Is that right? Check that. Okay. The person who
Yes,
give
sir.
me the answer, is that right? Betul tak? Okay. So we look at, tak payah tengok ni dulu. Okay. We just look at because if you put in that one, we will end up with, tapi senang je cerita dia. Okay, if you, okay, tak apa. If I put these two inequalities, all right, here, if you look at this feasible region, this is open area, okay, open feasible region. It go down all the way, all right. Therefore, there are only two corner points. Call it point A, that's point B. Now, I put in this x bigger or equal to 0, y bigger equal to 0. This is relevant, all right. This is the inequalities automatic. Oh, this one is built in, automatic. When you have applications, because you don't look at negative x or negative y. We only look at positive x, positive y. So if you take into account y bigger or equal to 0, then it's only that part, and x bigger or equal to 0, that part. So now, if you take into account that constraint, what is our new feasible region? What is the new boundary that you have to add to the one that we already have? The point AB will be there, okay? But you have additional boundary, yeah? Where is it? Okay, tell me. Okay, now where is the new, what is the new feasible region now?
I think at the small area, sir.
Yeah, small area, what is the new boundary? Just tell me the line. Because you see, y bigger than 0 will be all this area. Okay, that will be y equal to 0. X bigger or equal to 0, all this area up here. So what is the new small boundary? What is the, I'm sorry, not the new small boundary, the new small feasible region? Tell me the additional border. Where is the new border? Betul lah. What you said was correct. There will be a smaller area. Now, what is the area? Just tell me the line, okay? The line that make up the border now.
X is bigger than 0.
They will be bounded by what? By the x bigger than 0. That means the x bigger than 0 will be bounded by this line. Okay, will be bounded by this line. Okay, what is the other boundary? X bigger than 0, lagi satu?
Y bigger than 0.
Y bigger than 0. So that is the line. So now, when you consider only positive x, positive y, we only look at only that quadrant. Okay, the first quadrant. So the boundary will be what? The y-axis, the x-axis. Cut that point, AB is still the same, don't change. So that is our new feasible region. Okay, when you take into account this thing here. Now, how many corner points do we have? So here you have a closed region, okay? You have a proper area, proper shape. Now, what are the corner points? The additional corner points. Ada berapa lagi? Berapa lagi kita kena tambah tu?
Two.
Two. A, B, 1, 2. Itu je kan?
Zero,
Is there
zero.
any 0, 0, inilah. 0, 0 ni. This is another point. That's
Zero,
correct.
9.
Okay, what is the other point? Dia tak sampai 0, 9 sebab
Nine,
kita
nine
punya
zero,
visibility.
sir.
9,
90.
0 is 9, 0 is this one. Okay, 0, 0 is that one. What is the other point?
02.
02.
0, 2 lah. Sini ya. Okay, because that is the upper boundary. So you have now 5 corner points. A, B, C, D, E. But the 3 corner points we can identify directly from the graph. Because here you know it's 9, 0. Here very easy. 0, 0. And here is 0, 2. All right. The only points that you need to find is A and B. Okay. So if I take into account that y bigger than 0, x bigger than 0, which is what we do during applications, okay, then our feasible region, it will be bounded by positive x, positive y. So that will be always the boundary. The x-axis, the y-axis, we always form a boundary. If the feasible region dia dekat situ lah. Otherwise, it's not lah. All right. So now, okay, I put in those constraints. We have the corner points. So I got that feasible region. The corner points will be A, B, C, D, E. Banyak tu. So what I want you to do, you complete this at home. Okay. Complete this homework. I give you question 10, 12 kan. So this one you go siap aja lah. Finish it up. Okay. Alright. Any other question? Anything? So the visible region is the intersecting area. So sometimes, it is good that you use some different color so that we can identify the intersecting area. All right. Okay, good. So that is optimization problem, the system of inequalities, and you have the objective as a linear function. Now let's look at applications. For application, we go back to our first example. First example, where is it? Our first example, the one that we were looking at. Let me see. The one that we were talking about, the cappuccino example, the coffee machine, coffee maker, all right, where you have the inequalities, and then for that thing, if you have the objective, then we can use that thing untuk our example. So saya rasa ada dia punya continuation of the thing. Coffee maker Atlanta Fort Worth. I thought, they have the question in 4.2. I don't know. Because that Sierra Wood, CDF, Atlanta Fort Worth. maximization. Lepas tu dia bagi co-op. Dia tak. To find constraints objective function. Patut dia, patut dia sambung lah soalan tu. Bagi objektif, then sekarang lah cerita. Dia. Okay, ada. So you have the example that you have the apa benda tu? The inequalities. Okay, now you have the inequalities already for that factory. Okay, the CDF application. You have the inequalities. Yang itu kita dah buat lah. Now, what is the objective? Ada objektif dia tak? Ada objektif tak? Tengok. Okay. So let us look at that example, the CDF problem tu kan. We have already come up with the inequalities, and then we know the variables. Okay, I think we did that on Monday. So we have the inequalities. We know the variables. The variables are the number of hours. How many? We want to find is the number of hours for each plant. All right. In order to, if you don't have the objective, then susah. So we cannot do that because if I make up one objective, sometimes it can be wrong. So I can think of the objective later on. Because the objective maybe is not, because the objective can be what? Can be maximization of profit. But let me look at the some proper thing. We have the one that has a proper objective function. So kita tengok balik. Tengok ada example lah. Hari tu saya bagi example kat mana senang cerita. Kita bagi, look at example number 2. Okay, look at example number 2. Senang cerita. They have the objective. Okay, look at example number 2. On 4.2. It's already 11:13. So I think I'm going to start the example next class, because you have to come up with the whole problem. So we continue next week. So what I want you to do, you read this example, okay? Read this example. You identify the variables. You do it, okay? On Monday we'll do together. You identify the variables. And then you come up with the constraints. With the constraint, what I mean, the inequalities. Of course, everything is tabulated already, so that make our life easier. Sometimes it is not, so you have to come up with the inequalities by yourself. So I would like you to do that. Ini dia. So in order for you to do this, dia land co-op kan? Kita kena dia lain buat mana? Okay, dia sama je. So in order for you to do this, to get the inequalities, you also, it's the same example. You refer back to the example Okay, in 4.1. Dia sama aja. So I want you to do this. Identify the variables, come up with the constraints, inequalities, and then when we come back next week, we will get the objective. Okay, I get the objective, then you have the proper maximization, minimization problem. Okay, all right. So I'll give you 2 questions, for your practice. So do that. Make sure we can identify the feasible region, and then we will continue from next class. All right. Okay. Any question?
Yeah.
Anything?
I have a question.
Yeah. Okay.
So last week saya cakap number 30 for applications on chapter 4 inequalities linear programming. Soalan dia pasal profit. Saya rasa nak answer.
Question 30.
Yes. Yang rocker dengan bookshelf tu. Rockers and bookshelf. Sarawak product.
Sir, open mic ke? Tak dengar. Cannot hear you, sir.
Dengar kan? Hello? Okay. Can you hear me?
Dengar.
Macam mana tadi hilang? Okay, so what I was saying is that, okay, this is it. Question number 30 tu, the profit is the objective. Okay, the one I will do it on Monday lah. But you can find the inequalities. Okay, you get the inequalities, identify the variables, come up with the inequalities. So that would be the constraints. So when you form up the problem, you will see that the inequalities will be the constraints, and then you have the objective. So that question number 30, we'll put the proper complete problem Monday. Okay, but I would like you to try question number 30. Okay, I want you to try first. Just get the constraints. You don't have to worry about the profit. That will be it. On Monday, I will continue with the objective. Okay. All right. So thank you. Lepas tu 4.2 tu buatlah. Buat the example. Okay, the example co-op tu. So I think enough work for you already. So make sure try. Okay, you may not get it. I want you to try. Okay, if you try, you got it wrong. When we discuss, at least we know where we are going. If we don't try at all, then it's a little bit. Okay, all right. So I think I will stop here. I will see you again. Have a nice weekend. Assalamualaikum warahmatullahi taala wabarakatuh.
Waalaikumsalam. Thank you, sir.
Thank you, sir.
Waalaikumsalam.
Thank you, sir.
Thank you, sir.
Thank you, sir.
Thank you, sir.
Thank you. All right.
Thank you, sir.
Okay, thank you.
Sir,
Yes.
I have a question.
Yeah.
Untuk saya ada bagi homework exercise 4.1. Homework dia nombor 27.
4.1. Nombor 27. Okay. Alright.
So dekat sini dia cerita pasal ada Wellgood Company. So dia ada dua jenama, ekonomi dengan deluxe.
Okay, ekonomi dengan deluxe, right?
Lepas tu dia suruh kira semua tu assemble dengan paint. Lepas tu saya dah buat semua. So saya dapat 2x tambah 3y kurang dan sama dengan 24. Lepas tu satu lagi untuk paint punya saya dapat x tambah 1/2y kurang dan sama dengan 8. Tapi dalam buku dia terbalikkan. Jawab dia punya jalan kira dia terbalik.
Okay.
Jadi
can you see my screen ni? Boleh nampak saya punya screen? Boleh nampak saya tulis ni?
nampak?
Nampak? Okay. You know when you do this, like I said earlier, kita buat table. Okay? So you see where you go wrong. So if I make a table, okay? So what you have the economy, okay? And you have the deluxe. Betul tak? Deluxe. And then you have the requirement to production requirement. You have what? You have the assemble. Okay, assembly. Lagi satu pula. Lagi satu paint. Kita relate lah benda ni. Okay, I think the reason why you got it upside down because you mix up when you summarize the information, when we relate these two things. So if you do this, you see here the deluxe model. The deluxe model, betul lah. Deluxe model require 3 hours to assemble. 3 hours to assemble. Deluxe require 3 hours to assemble. And then 1.5 hour to paint. So the deluxe ni akan masuk situ. Okay. Now it doesn't matter whether you do it macam ni. Econ deluxe kat sini ke assemble situ sama lah. Doesn't matter. Okay. When you table it will be exactly same order. So I do it this way, so you don't have to worry about this thing. If you do it the other way pun tak apa. The thing is the deluxe. Okay, come under the deluxe. 3 hours assembly, 1.5 hour paint. Lepas tu mana? Lepas tu to the economy model require 2 and what? 1. See? Now you go to your table. Did you do a table or you don't?
Yes, I do.
Do table, where is it wrong? Probably when it's wrong, you put in the numbers. That's where you got it wrong. And then the maximum number of assembly.
Okay.
Tak apa, saya siapkan. Assembly, what? Assembly. Now the bigger or less than the limit tu is on the assembly. See here the assembly hours available is what? 24. 24 dia kata apa? Available maximum. Maximum means less or equal to lah. And then you have the other one is 8, less or equal to. So this is the inequality. Okay, less than or bigger than. So when you have the maximum number, minimum number on the assembly end, so that means the number of each type will be X and Y. Inilah variable. Okay. So if you go into more detail, you have X. It's not economy. It's what? It's the number of economy. Economy apa? Economy cheapest. Okay, economy cheapest in units. And then Y, the deluxe lah. Okay, unit. So now what is our equation? Our equation 2x plus 3y. I'm sorry, not equation, inequalities. 2x plus 3y less or equal to, tadi dapat apa? 2x plus 3y less. Dapat ni?
Saya dapat answer. Cuma dalam buku dia buat 3x tambah 2y kurang dan sama dengan 4.
Dia
terbalik.
Salah. Buku tu salah.
So bila jawapan akhir dia, buku dapat 46, saya dapat 64. Sebab tu saya nak tanya boleh.
Salah. Bukan kita salah, buku tu salah.
Okay, buku kesalahan ni.
Sebab saya tak ada lagi orang tanya buku tu lain dengan tu. Setakat ni tak ada orang tanya. You are the first one who say the book answer is the other way around. So you get the same, I got the same. I think the mistake is on the book. Okay? So kita check balik ya. Cuba check balik. Probably we are wrong. But I don't think so. Because the way we do it, that's all.
Jawapan saya dengan buku tu sama, tapi sebabkan XY terbalik, so kita balik semua tu.
Itulah saya rasa when they come up with the solution, dia orang yang terbalik. Dan mungkin orang buat sebelumnya 3-2, you know, 3-2.
Macam saya kan, saya letak ekonomi dulu baru dilas kan. Tapi dia letak dilas dulu baru ekonomi.
Kalau dia letak dilas dulu baru ekonomi, betul lah, sama lah.
Sama lah jawapan.
Sama lah. So the book do it this way. You je confuse pula. Sama je actually. So I thought the answers are different. I mean the answers are different. So here what they do is X ni is the deluxe. So macam saya kata gitu, which you assign X, which you assign Y, doesn't matter. It's up to you. So the book use X deluxe, Y economy. So macam tu lah dapat. If you got 4-6, kita akan dapat 6-4. But when you describe the answer, sama je. If you say 6-4, that means 6 units of deluxe, 4 units of economy. Because the way we do it like this, for 4 units of economy, 6 units of deluxe. Okay, so betul. Okay.
So kalau jawab dalam exam, jawab dalam exam pun boleh dapat betul lah.
Memanglah. Takkan you have to follow me? How do you know? How do you know I put X apa? Unless I say, okay, unless I put it there, X to be economy, Y to be deluxe. Then you have to follow lah. Okay. Tapi kalau in the question, dia tak cakap apa-apa, macam dalam ni, dia tak cakap apa-apa. Alright? Dia tak cakap apa-apa. So, it's up to the ni lah, to you, to the individual, to assign. Okay? Tapi the answers are same lah. Alright? Alright.
Okay,
tadi
thank you,
answer dah
sir.
masalah. Tadi answer dah masalah. Ini bukan answer dah masalah. So make sure that is understood. Alright? Either X or Y doesn't matter. Okay.
Okay, thank you, sir.
Okay, thank you.